This lesson is a continuation of the normals lesson. And in this lesson, we're going to take our low resolution mesh and we're going to put it into a game-based system. Now, in order to do that, we have to export this file into a format that our game-based system understands. And that's done through a process called an interchange format. So a Blender file is saved as a .blend file. And if you're working in a different 3D package, it would save under its own format. And importantly, that is a format that only Blender understands. And again, for any other 3D package, that's a format that only that 3D package understands. So we have to export this file to a format that any package or the target package understands. So to do that, we're going to select our low resolution mesh. And then we're going to come to File, Export, and we're going to choose FBX. Now we could also choose OBJ and DAE, in fact, for Vortals, but FBX in this case is a preferable format for us. So we choose FBX, and now we have a bunch of options to export. And whenever you export, these options will be different depending on what your plans are. In this case, I only want to export the plane, and so I'm going to choose Selected Object, and that means only the object I currently have selected will be exported. And then you'll notice things like scale. So we can choose a scale to export this mesh at, because different packages will work at different scale sizes. I'm going to leave this as is, and then our up vector. Now, depending on the package you're targeting, different packages have different up vectors. Now, what that means is currently this model is oriented in a direction based with a Y is up. Now, other packages like 3D Studio Max have Z is up. So the Z axis will be up. And all that means is that when this loads into that package, it might be rotated, and you will have to manually rotate the object when you load it in. But I'm going to leave all of these together as is, and I'm going to choose Export FBX. And then for comparison, I'm going to select the high resolution mesh, and I'm going to do the same thing. Now the first thing to note when comparing the two meshes is how much smaller I've managed to make the low resolution mesh. The low resolution mesh on the disk is 30 kilobytes, whereas the high resolution mesh is almost 40 megabytes. So we've saved almost 40 megabytes of space by going through this process. And that's pretty significant when you talk about sending data across or loading data. So now let's come to Vortals. If this is the first time you're using the Vortals interface, the starting point is to choose New Vortal over here on the top left. So we click that, and that takes us to a new menu, and we're going to ignore all of this and just choose Create. And we're given another menu, and we're going to choose 2D Slide. And that just gives us an introduction 2D slide. And we're going to do nothing here, and we're going to choose Add Slide again. And now we're going to choose AR Slide. And this is an augmented reality slide. And again, once we choose that, there's a whole bunch of options here that we're going to ignore and just choose Create. So this now takes us to augmented reality space. This is 3D space that anything you put in here, when you load this onto your mobile device and replay this as a presentation using the Vortals app, this will play in augmented reality. And what we're going to do is we're going to load in our low resolution and high resolution meshes to see the difference. So let's start with the high resolution mesh. And the first thing you notice is that it took a very, very long time just to load this model. And that's one of the consequences of having a very large file, is that it will take a long time for the file to be copied into memory. So here we have our high resolution mesh, but currently it doesn't have a color. And so we want to choose our color image. And again, you see we apply this image, and this is a very, very, very high res image, and it's taking a very long time to load. And this is a very fast PC. This computer is a top-end gaming system, and you can see how long this took to load. And now that we've loaded it, we have a warning that's popped up. And this warning is a very important warning to consider if your target device is a mobile. So this warning tells us that the resolution of the texture is too large for a mobile device, and that we have to reduce the size. Now, I'm going to choose OK and talk to you about why. So all graphics cards have a limit to the size of the texture that they can load. For mobile devices, depending on the age of the device, this limit could be a 4096 by 4096 limit or a 2048 by 2048 limit. So when you load textures, even if you have enough RAM to handle the textures, you might find that the device itself cannot handle it. Now in Vortal's case, we deliberately don't check whether or not you've loaded in a texture the correct size for the mobile device. This is something that we leave to you to understand and to choose. So this high resolution texture on a high resolution model, if you try load this onto a mobile device, it will simply crash. The app will shut down because you've tried to use too big a texture in the video RAM. So let's delete that and load in our low resolution mesh. And the first thing you'll notice that it loaded in almost instantly because this is a very, very small mesh. And so now let's choose our color image. And in this color image, we chose 2048 by 2048. And now we are given a different warning. So this tells us that it may cause problems. And that means with really old devices, this might cause problems. But in fact, it's highly unlikely to. And so I'm quite okay with that. And I'm going to choose Don't Show Again. And I'm okay with that because I'm making an informed decision about the target mobile platform that I'm going for. So here we have this model with a color map, but you can see the reflection doesn't seem to have any effect, doesn't seem to have any bump, but it's just a flat reflection. So what we need to do now is load in our normal map. So we come to Advanced Options, and we choose Advanced Options, and under Advanced Options, you can see there are a number of higher end options for the shader. And we can choose Normal Image. Under Normal Image, we can choose this file, the normal map that we created. And now, suddenly this has the appearance of height information. So now let's go to Slide Properties, and choose Turn Off Default Lighting, and choose Save. And so when you load into Vortals comes with lighting already default enabled. And we don't want that at the moment. What we want to do is create our own lighting system. So if we choose to create light and choose point light, we can now move this about to create a lighting solution. And you can see again, when you move the light around, there's a sense of height data to the reflection of these rocks. There seems to be height, even though we know that there is no actual geometric information. So the important thing to look at, however, is when I move this light, you can see a shadow that is cast by the actual geometry. Now, what that is telling you is, even though there is the appearance of information, the original mesh still remains low resolution. And that'll be something that you have to think about when you're trying to cast shadows in any scene that you're trying to create, because you are simply faking information. It's not real information. And so when the system does some math, it'll be based on the real information, and you will have very sharp, jaggy shadows. So this is a scene from the game The Witcher. And if we look at this tunnel that we're currently in, it feels like there's lots and lots of detail. But if we look closer at the lighting solution, we can see the rock is lit by this little flame here. And if we look at the shadows on that rock, despite the rock appearing to be highly detailed and having lots and lots of jagged edges, if we look carefully at the shadows themselves have very, very straight lines. And that tells us that the actual geometry that this rock is based off has a very low res mesh behind it. And you can start to see that all over this game, because this is a very large open world game, and so there's many different textures and models that have to be loaded in. And in order to make this game actually playable, the game designers have had to think very carefully about where they've put their geometry. They have a budget, so to speak, for how many textures and how many models they can load in at any time. And again, another clue in terms of the low resolution geometry. On the ground here, we can see where this geometry intersects with the main floor. You actually have very sharp edges to that. And that, again, is a function of a low resolution mesh that has been given all the appearances of high resolution via this normal map process. So the last thing I'll leave you with in this lesson is a question for you to discuss. In Blender, I've loaded in a point light, and a point light in Blender means that all of the lighting is coming from an infinitesimally small point in the middle of this circle here, and it's radiating out and colliding with this low resolution mesh. And from that you can see those sharp, jaggy shadows. This is typically how a game lights a scene. They run off the same ideas, where a game will have a point light system. Blender, however, being a render system, also has another trick up its sleeve. Instead of being a point light, we can make the light emanate from an entire area, a volume sphere instead of a single point. And you can see the effect that has on the shadows. That makes these shadows much more soft and diffuse. And so even though there's still the appearance of height information from the normal map that we've created, now those jaggy shadows are minimized, and the negative effects of having such a low resolution mesh are reduced. This process is generally not done in games because it is such an expensive computational process. But games still do use these area lights to create lighting solutions. So my question to you is, given the process that we've followed in creating a normal, taking height data and baking it into a low resolution mesh to create the appearance of height data, how do you think they create the appearance of area lighting data?